welcome in our YouTube channel Physics by TC Chauhan. Today we are going to discuss about electric field and electric field intensity. What does it mean by electric field? What does it mean by electric field intensity? Electric field is a region around a charged particle in which another test charged particle experience either attraction or repulsion. Suppose this is a test charge, suppose this is a charge around which a region is created in which another test charge is small charge, unit charge, which experience either attraction or repulsion. Then this region or this field is known as electric field. This is all around the charged particle. Now what about electric field intensity? Intensity means electric field intensity is force acting on unit charged particle kept in an electric field. How much force is acting? F upon Q naught. It is a vector quantity. Its another formula is E is equal to V upon D. It is voltage upon distance. It's very simple. It can be applied by taking two metal plates and connecting with a battery. Suppose this is a battery. This will become positively charged. This will become negatively charged. Then a field or region is created in between, and that field is E, that is electric field. It depends upon its voltage V and distance between plates D. Now, if voltage is increased, electric field will get increased. If distance is decreased, electric field will get increased. This is all about the field intensity or electric field. Its SI unit is Newton per coulomb or volt per meter. None other, same thing. Newton, you can say Newton per coulomb or you can say volt per meter. The same thing is there. Now, what about electric field intensity due to point charge? How it can be obtained? Suppose this is a point charge Q. You have to find electric field intensity at this observation point P. Then, first of all, you have to put a test charge Q naught. Electric field intensity E is equal to, F upon Q naught. Force, that is by Coulomb's law, E is equal to Q naught upon R square Q naught. Q naught will get cancelled. E will be KQ upon R square. This is electric field intensity due to point charge. What about K? Equal to 1 upon 4 pi epsilon naught Q upon R square. Now, what about the medium? If we have to find about medium, then E medium will be equal to 1 upon 4 pi epsilon naught epsilon R Q upon R square, or E medium is equal to 1 upon epsilon R into E. That is, E medium will be less than E. That is, due to medium, electric field intensity decreases. This is all about the electric field intensity. Now, what about vector form of electric field intensity? It will show the direction. In the case of vector form, E vector will be equal to KQ upon R square R cap. This R cap will show the vector form. R cap will be equal to R vector upon R. Just put its value. E vector is equal to KQ upon R square R vector upon R. Then this will become R cube. E vector is equal to KQ upon R cube R vector. This is vector form or vectorial representation. If there are several charges present, then what about the net electric field intensity? These are several charges. Its distance R1, R2, R3, Rn. Then what about the electric field intensity, resultant electric field intensity? That will be E vector is equal to E1 vector plus E2 vector plus E3 vector dash 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 En vector. Then what about E1? That will be KQ1 upon R1 cube R1 vector. We have to put in terms of vector, remember. What about this? KQ2 upon R2 cube R2 vector dash 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 KQN upon Rn cube Rn vector. It can be taken in summation sigma I is equal to 1 to n K Q I Ri cube Ri vector, where I value of I will change from 1 to n, and you can write this whole in single term in terms of summation. This is about electric field intensity. Now the question arises, what is the direction of electric field intensity? In the case of positive charge, the direction of electric field intensity will be outwards. In the case of negative charge, the direction of electric field intensity will be inward. Remember, student, in the case of positive charge, electric field intensity will be outward. In the case of negative charge, direction of electric field intensity will be inwards. Now we do the application of electric field intensity. In the case of application, there are several numericals based upon electric field intensity. These are useful numerical. These numericals are very helpful in recent competitive examination, forthcoming competitive examination, as well as in 12th board examination. These are useful for NEET, JEE and 12th board. Now, first application is question number first. If three charges are there, these charges are situated at corners of an equilateral triangle. Side of equilateral triangle is L. What about the net electric field intensity at centroid? So due to this charge Q, the electric field intensity will be even. Due to this one, the electric field intensity will be even. And because of this one, electric field intensity again even. The question arises, why these are even? Because charge is same and distance, this R will be same from centroid to each vertex, this R will be same. Now what about the resultant? We have to find resultant of these two. Let us find. If we are going to find this angle, it is 120 degree and their resultant will be in this direction. What about the resultant? This resultant will be E is equal to under root E1 square, by vector form we are taking E1 square plus E1 square plus 2 E1 square cos 120. You know cos 120 will be minus 1 by 2. This 2 will get cancelled and minus E square plus E square will get cancelled. So you will have even. This is even. This resultant is even for this one and this one, the resultant is even, and this even will be exactly opposite to this one. Both are exactly opposite. So resultant E dash will be E1 minus E1 is equal to 0. So net electric field intensity at the centroid will be 0. Now what about the question number second? When we take a square, at each corner of a square, 4 charges are kept. These are identical charges. Square having same sides, that is side of each part is same. Each side of square is same. Then you have to find electric field intensity at the center of square. What about the electric field intensity at the center? Due to this charge, it is even. Due to this charge, it is even. Because of this, it is again even and it is again even. These all are same. Why? The question arises, why these are same? Because the charges are same and distance from center is same in each case. Then the resultant will be E is equal to E1 minus E1 plus E1 minus E1 will get cancelled. The resultant will be 0. Another question is, this question we are taking on the base of simple data. Question number third, you are given a particular charge Q. This particular charge Q is 18 microcoulomb and you have to find electric field intensity at a distance 9 centimeter from this charge 18 microcoulomb. The first of all, we have to convert it into coulomb and meter because SI unit is essential for solving the numericals. So here there will be 18 into 10 to the power minus 6 coulomb and here there will be 9 into 10 to the power minus 2 meter. This is displacement or distance where we have to find electric field intensity. Then electric field intensity E will be KQ upon R square. You know the formula, E is equal to KQ upon R square. K is 9 into 10 to the power 9. Q is 18 into 10 to the power minus 6 upon R square. 9 into 10 to the power minus 2 into 9 into 10 to the power minus 2. This is in meter and square is there, that's why it is kept twice. This 9 will get cancelled. 9 2 ja 18. Now, what about this? Here, 2 into 10 to the power. You have to solve the powers. It is 9 minus 6 plus 2 plus 2. Then what about this? 2 into 10 to the power. 3 plus 2, 5, 5 plus 2, 7 Newton per Coulomb will be the answer. This will be the determination of electric field intensity. Another application is based upon the equilibrium of the charge when it is kept in a particular electric field. The question arises, how does equilibrium takes place? Whenever you have positive charge, the equilibrium is required. Whenever you are having negative charge, equilibrium is required. Like if you have to keep a charge either positive or negative in an electric field and it should remain in equilibrium, that it should be freely suspended in air. What happened? For free suspension, the weight should be equal to the force, and weight will be mg, force will be QE, then the concept will be QE is equal to mg. Either negative or positive charge, if force is equal to weight, then this will remain in equilibrium, otherwise not. Now, question arises, how does the positive or negative will remain suspended freely in the air? It depends upon direction of electric field intensity. For positive charge, the direction of electric field intensity must be upward. Remember, this is very important concept. Direction of electric field intensity must be upward. And for negative charge, direction of electric field intensity must be downward. Otherwise, it will not happen. But the equilibrium condition is, this is very important question, but the equilibrium condition is QE is equal to mg, force F is equal to weight W. This is the basic equilibrium condition. By using this, you can find electric field intensity required. E is equal to mg upon Q. This is required electric field intensity to keep any charge in equilibrium. This is all about for application of electric field intensity. I think this session become very useful for you. Please do subscribe, share and like our YouTube channel Physics by TC Chauhan sir. Thank you. Thanks a lot.